In the 10th lecture of probability theory, we considered the second specific case of discrete random variable, the geometric random variable. We gave its definition in terms of the numbers of Bernoulli trials done in order to obtain the first success. We demonstrated that its probability mass function satisfies Kolmogorov's axiom 1 and axiom 2. For the latter proof, we used the well-known formula to compute the sum of a geometric progression. We then computed the expectation and variance of the geometric random variable. To compute the expectation and later the expectation of x times x minus 1 for the calculation of the variance, we used a trick and the properties of the sum of a geometric progression. We finally discussed the memoryless property of the geometric random experiment. To understand the meaning of this property, we consider the example of the lottery. The knowledge of the numbers obtained in the previous extractions does not help in forecasting the numbers of the next extraction.